So I'm going to start, and because I have like no time to do this in. So, hi everybody, my name is Marshall. This talk is about robots, DevOps, IoT, and mentoring future engineers. So, slide is an awesome picture of a bunch of the robots that my students have helped develop and create over the last couple of years. I'm going to read this statement, which is that these 150-pound robots were built by high school students and mentors to compete in a yearly technical challenge. They must be built and compete over the course of about 12 weeks. And each team, which by the way there's about 3,000 teams globally, must work within their knowledge and means to make this all happen. And I'm actually going to reread that statement real quick so you guys understand what I just said. These industrial connected prototype products are delivered to an audience and must conform to regulations that change yearly. They are manufactured and programmed in a limited time frame using a mixture of old and new technology as well as rapidly evolving processes by large groups of high turnover new employees led by only a few veteran team leaders. That's crazy. All right, so what am I actually talking about? I'm actually talking about doing a whole bunch of stuff with giving students the skills that they're going to need to kind of survive in the coming world, because it's changing. I think we all know that. That's why we're here. It's what Pat talked about this morning. So we use a whole bunch of different technologies to do what we do. That includes C, C++, Python, Perl, Bash, JavaScript, YAML, a little bit of Lisp, not a lot. So, really. A bunch of Rails, because we actually do a lot with logging stuff for students using custom-built apps, which is really cool. We have a bunch of students who just started 2 years ago doing a lot of work with the Unreal Engine, which is amazing. And then for a while, and not so much anymore, we were doing a little bit of LabVIEW, but we're really not now, and I'll explain that in just a minute. So, we do a bunch of stuff with computer vision, machine learning. Try and teach how to use Docker, VMs, Travis CI, all of these awesome technologies that a lot of people here really wish they could use. So we're actually doing this, and we're doing it with high school students to build robots. That's really cool. We use a lot of SolidWorks as well, which is also fantastic, and we're getting ready to actually virtualize some SolidWorks instances on top of an ESXi host so we can serve out SolidWorks to students, which is really cool too. We teach programming, we teach bug reporting, bug tracking, all the awesome things that come along with development. We teach the DevOps lifecycle, although we kind of don't tell them it's DevOps, we just trick them into doing it. So these students come away from this, and this is the only model of programming that they actually understand. So when they get to work for your companies and you guys don't have this in place, they're not going to hang around for very long, hate to tell you. So we teach physics because gravity's hard, as it turns out, and getting a ball to travel 50 feet or whatever we're doing for that particular year, that's really difficult. So, and then on top of that, we teach time commitment and time constraints, which is really hard as well. So they learn a bunch of business skills in the process. The best one is empathy. They actually learn how to empathize with other team members, with other people who don't understand as much as they do. They learn how to empathize with other teams that struggle with the same problems they struggle with. So, this past year, it's exciting, I know. So, all right, this past year, we made a big transition. We actually transitioned our entire code base out of LabVIEW to an entire C++ framework called ROS, which is the robot operating system that was developed at Stanford and this company called Willow Garage. So, we did that through some insane shenanigans involving Docker containers. And what you actually see here are the legitimate statistics from our GitHub projects. You can see 2017, we had 210 commits, and we had 2 contributors. So it's a team of about 40 students. I'll show a picture of them in a minute. They look awesome. But the big thing we did this past year was introduce Travis CI and Docker to deal with deployment for our container image, which in turn allowed us to get students running in the code base quicker. And then on top of that, implemented Travis CI for actually doing continuous integration work with the code. And I'll show that as well in just a second. What that enabled was this awesome culture where you end up with things like this. This is actually a screenshot of Slack. And what you can see, if you guys can read it, and I hope you can, you're actually seeing the chat history of my students this past year making fun of each other for breaking the code. So every time they'd kick off a git commit, push it out, Travis CI would grab it, it would do a build, it would report in Slack, hey, this succeeded, hey, this failed, and then high school students would make fun of each other and tag these things with emojis. And this was motivation for them to make the next build not fail, or make it fail faster so that they could keep doing this. This is DevOps in action with high school students building robots. So So yeah, we're doing a whole bunch of awesome stuff with VMware. We actually use a lot of the VMware technology to make this happen. We do this by giving them copies of Workstation and Fusion. So what that enables is them to get up and running quickly with a development environment. We have some standard images for our VMs. We also have Docker, so we can run Docker within the VM environment and kind of make things go from there. So again, we're looking at doing ESXi work. We've actually been playing around with this recently. One of the cool things that's coming out now with ESXi is the ability to deploy workloads not just for SolidWorks or kind of dedicated virtual GPUs, but also to use those GPUs to do more machine learning type workloads. So the team is actually sponsored by NVIDIA in part, which is awesome because we use a lot of their stuff to do the awesome things that we do. So rapid development environment, kind of key to making this all work, and then Travis CI, which serves as the continuous integration on top of it. So, how is this related to the Internet of Things? Well, our robots, the ones that my students and I build and my awesome team of co-mentors, have a ton of data off of them. We started using ROS because we had so many sensors and we wanted to integrate more, and it's really difficult. So what we ended up doing was kind of compiling all that data. ROS dumps everything into what's known as a bag file. The bag file contains all of this data. It's data from stereoscopic cameras, it's data from LiDAR systems, it's data from the odometry sensors on the wheels, the encoders that we have, and there's tons of process and just kind of application state data that gets generated as well. So CPU load, memory workload, all that kind of stuff dumped into a file. We play about 70 matches per year, my team. However, overall throughout the world, again, there's over 3,000 robots. There's 6 on the field at once. If you do the math, this ends up being like a petabyte of data a year that could be generated from these things. And again, this is high school students playing with robots. So, this is an awesome quote. It's from a very good friend of mine. He's actually an alumni of the school that we're doing all this out of. So, Carl's quote is that in 4 years, that student will be making $100,000 plus. And I don't know any investor who would turn down that kind of ROI. So on average, we spend about $2,000 per student per year to make this happen. That $2,000 comes from a ton of awesome companies that donate to these programs to enable these students to do this work. That $2,000 is paid back many fold over for these students to walk away from this with the experience that they get. Those are my awesome students. You'll notice that they're wearing zebra-striped pants. The zebra-striped pants is a thing with our team. We're actually called the Zebracorns. It's a combination of a zebra and a unicorn, if kind of playing at home there. So what is this really all about? It's really about mentoring these students and getting involved and transforming them. So it's about inspiring them. It's about teaching them these skills that they need to make the world a better place. It takes a lot of time and energy on my part and on my fellow mentors' part to get involved and kind of make this change and transition happen. And sometimes it's a little painful, so I spend a lot of time working with students that sometimes they're a little stubborn and they're ridiculously smart, so they've kind of got some right to be, which is awesome. But it's about developing the students, but it's also about developing us. So one of my co-mentors actually recently left his job and is now going to work for NVIDIA doing autonomous car stuff, which is awesome. And I think part of the reason, and not the entire reason, but certainly part of it that he was able to go off and do this awesome stuff with them has to do with the fact that he's been working with ROS, working with students to deliver an autonomous robot that uses some of the same technologies and same concepts that these cars are using now. So this is an awesome picture of some mentoring in action. This is actually taken at one of our events. So the girl you see down here her name's Olivia. She's actually 15 years old. She knows more Unix and Linux than guys in their 50s and 60s that I've worked with that have been doing it their entire lives, who can remember back when Unix was AT&T. So Olivia is wickedly smart and clever and amazing, and she's one of the many reasons that I keep doing this, because these students blow me away year after year with what they know. So how can you help? You can go find a team. The place to do that's firstinspires.org. There's tons of teams. There's about 3,000, or say over 3,000 globally. There's a ton in Michigan if you happen to be from that area. There's a ton all over, especially around the big hubs where you would expect them to be. So you can find an event. So with 3,000 teams, there's a ton of events that happen. So find an event, take your your kids to it, take whoever to it, go to it, take some people from your company. It's fun to watch robots move around on a field. So involve your company on that note. So you can donate some stuff. So these teams, not just mine, but lots of them, they need resources to enable these students to do the awesome work that we're doing. So you can donate cash if you don't want to donate stuff. If you don't have an old laptop or tablet lying around, then that's okay. So cash works. Sometimes that's what they need. And then lastly, if you want to get in touch with me for any reason whatsoever, so you can find me online at marshall@team900.org or at marshallm900 for my Twitter account. Again, my team is the Zebracorns. That's our awesome logo. So, and then lastly, thank you to the VMware Foundation, the NCSSM Foundation, which is the representative of the school that I worked with for all of this, NVIDIA, John Deere, First, and a ton of others. And I'm here if you have questions. Thank you.